Okay. Good day, Sir Ernesto Vergara Jr. I am Sigmund Bansi of Mechanical Engineering fourth year student taking up ECE20L-2 of section E05. Today I will be talking about a project uh, in our class. In this project, uh, I will be doing a circuit which is about full wave linear power supply type of circuit. So uh, here, okay, I'll be doing it now. So the first component we will be needing is the voltage supply. Okay, and then the next one is the next the next thing we're gonna do is to is to uh, to to look for this voltage dependent voltage source. Okay, and we're going to connect it we're going to connect it. Okay, and the next step is to uh, let's put this resistor 1 on standby, and this resistor 2 we rotate it as we will be needing it on this side of the circuit. So the next step is we will connect this to this, and yeah, uh, what's next is to cre- create a silicone diode. Our next step is to create a silicon diode uh, here. It must be facing downwards. Okay, and that's for diode number 2. For diode number 3, we rotate it facing upwards. We try to make it as linear as possible. Okay. Does that work? Okay. And diode number 4, is also facing upwards. Around this. Let's move it a bit up. Okay. We can fix that later. So the next part is to create this path. Okay. Okay, oops. Okay, let's see. There. Nice. Okay. 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 The next step is to oops. The next step is to connect it there, and from here we connect it towards this. Then we look for the next component. We look for the next component, which polarized capacitor. We put it somewhere here. Okay. Okay. And then we connect it from there. Then from here to there. Let's put a ground here. as per stated in the PDF. So our next task is to attach a resistor. From here we create the resistor and diode again, but this time our goal is a Zener diode. Zener diode there. All facing up. Okay. Then we connect all diodes, all Zener diodes together like that. Oops. Okay. Next up is resistor 4. Try to make it aligned with the with the fifth diode, then fifth resistor align with the sixth diode, seventh diode align with the sixth resistor, about that. Okay. Connect from here to there. And from here to there. Connect here. From here we connect it here, and from there we connect it here. Okay, the next step is to label each component. The in this component we are to put sign 0311.1760. Okay, but first we adjust it so that it will be visible. Okay, this one for the transformer we will put a value of 0.1. For the second resistor, our value here would be 100. For this first diode, it's a silicon diode of MERS 320. Okay, hold on. I'll just move this here and move that there. Okay. And then here I will create I will look for MERS 320. There, and also another MERS 320. For this, okay, hold on, let's adjust this. R1. Okay, that's about right. The value for this R is 10K. Ay, 10K. The value for this polarized capacitor would be 100 mu, which is 100 micro. This third resistor is also 100 in ohms in value. These three diodes you can see here, Zener diodes, their configuration is UMC6_2K. Okay. Now the last part is to create the create the tran. So so the tran that we are supposed to use here is zero, dot tran 0, 1, 30M, and 100M. So there you have it. So here is the schematic diagram uh, of a linear full wave bridge type linear power supply type of circuit. So in the next part, I will be discussing about the address. Uh, Good day, Sir Ernesto Vergara Jr. I am Sigmund C of Mechanical Engineering 4th year and taking your subject ECE20L-2 of section E05 uh, first term of 2021 to 2022. And today I'll be talking about the project in our class, which is about full wave linear power supply type of circuit. And as you can see, this is the circuit that I have made, and and here um, uh, I will explain how it's made. So first, uh, first um, this this power source is voltage the voltage, and I have to we are tasked to put sine 0311.17, then 60. Then we next have to find the uh, we next have to find E1, which is this one. Okay, and and then next is resistor. First, resistor 1 is put here, located there. Then resistor 2 is located here. Then uh, we have the we have the four silicon diodes of MERS 320. So the first silicon diode MERS 320 is facing downwards. Then the second silicon diode of MERS 320 is also facing downwards. The third silicon diode is facing upwards, but here, put here, and the fourth silicon diode is facing upwards, located there. So we made, after creating this connection, uh, I I created this other connection towards this area, but I put the in the middle of it, I put the first resistor here with the value of 10 k ohms. Yeah, and of course, as per the given, there must be a ground. So there, and I connected it to this wire. from there, we created another connection here, which involves a uh, which involves a pol, pol cap or polarized capacitor, which I labeled C1 and the value of 100 mu. Then for the R3 is 100. Then after which uh, I created this connection here, that connection, and and I made this connection to the diode 5, 6, and 7 facing upwards, and the type of diode is UMZ6 underscore 2K. These three diodes are the Zener diodes, and another is the resistors. So this three resistors you can see here, based on the problem of the project, they are initially of no value. In other words, they are variables. So I changed them. I chose the values 3.3K, 6K, and 6.8K. So, uh, yeah, um, with the tran of dot tran 01, 30M, and 100M. Now let us run it. So here we add trace VN005, VN006, and VN009. So as you can see, we arrive at this figure, and in this figure, uh, we have the values of 6 volts approximately, 6 volts approximately, 12 volts, and approximately 18 volts. So as you can see, if you look closer, uh, the line of V the line on the 6 volts has most number the most ripple, and the least ripple is of the 12 volts waveform, and the one that has almost no ripple is that of the 18 volts waveform. So as you can see, uh, we can infer that from here we can infer that the R for um here the R for which is 3.3K, the is this one. So the lower the resistance means uh, it produces the least noise and constant and least frequency amongst each shown in the figure. Then the 6K ohms of this resistor 5, uh, there is this the ripple, and then the straight line afterwards, the next least or the middle, and lastly, as you can see, the 6 volts here, It's the one that has the most number of ripples given. So here in this most number of ripples given, uh, shown, produced here by the R6 or 6.8K in value, uh, we can infer from this uh, findings that the higher the frequency means the higher the resistance means the higher frequency of the waveform. The lower the frequency, the lower the resistance, the lower the frequency, the least amount of waveform. Therefore, the amount of resistance is directly proportional to that of the uh, frequency. Now, another thing is, uh, as we increase, as we uh, increase in voltage, we decrease in resistance based on the graph and the schematic diagram provided. And as we decrease in voltage, the resistance increases as well. So that's about it. And yeah, thank you very much for listening.